Hello, and welcome everybody to today's seminar. It's very nice to see so many of you here, and I'm using the microphone because we are recording everything, so I would also like to welcome those who are watching it on the streaming channel that we have. So just to introduce the seminar myself a little bit, my name is Nina Kirchner. I'm one of the two directors of the Bolin Center, and we have this Bolin Center seminar series which started this year. This is to give the 8 research areas of the Bolin Center an opportunity to explain what they do, to present their research, and these research seminars are given at a fairly general level, so not too many details, I hope, so that it's open for the other research areas to check in and to check out what is going on in the research areas, actually. Mm-hmm. And today it is research area 7. We have been going numerically through all the research areas. Basically, we started with research area 1, and now it's time for research area 7. And then I can hand over to Sarah, who will be introducing today's speaker, and then we can enjoy Kevin Bishop's talk in just a second.
Yes. Kevin Bishop, so you are well known in Sweden. So Kevin is a professor of environmental assessment and Vice-Chancellor at the Swedish University of Agricultural Science, SLU. His research identifies human-influenced aquatic ecosystems and distinguishes it from natural variability in space and time. Forestry, mercury, and hydrology are some of the major issues he has worked with in Europe and Africa. So we are very, very happy to have you here, Kevin. And also I can say that I'm Regina and Christopher. We are the RA7 co-leaders. So welcome to this fantastic seminar.
Thank you very much. Do I need to use that?
I don't think so.
Oh, good. Wow. Oh, boy. Yeah. Great. I need. Right. I'm from the Italian, so I need my hands to be able to express things. So it's a great pleasure to be here, especially since I've gone into administration to be able to talk about research. I feel like I'm playing hooky from real school. And talking about forests and water in Africa is one of the things that I've really had a great privilege to get involved with and learn a lot myself in the last 15 years. And I'm very glad to try to give a bit of a story of some perspectives about the role of land management in, you might say, the water cycle. I won't say climate, but certainly in the availability of water. And I start with this picture, which is hopefully you recognize the Nile River in Cairo. And Egypt gets 100% of its water from the Nile River. It's a birthplace of civilization, and it's a great place for vacation because there's no rain that ever falls there. It needs rain from other places. And much of that rain actually comes from the highlands of Ethiopia. The Nile has one of the largest, if not it's the longest river in the world, one of the largest watersheds, but 80% of all the water that gets to Egypt comes from 7% of the landscape, and that's the Ethiopian highlands. Here's sort of the hydrograph of the annual flow in the Nile River at the Aswan Dam. 80% comes from one little bit of land in the highlands. And you might say, oh, it's wonderful to be in the highlands there with all that water. But it is a contested resource because the Egyptians, being in their civilizations, totally dependent on this water. It's been very awkward if Ethiopia might want to do something with that water. Putting up dams was essentially out of the question until a few years ago when the political instability in Egypt and some other things let Ethiopia see an opening to actually start building the Grand Renaissance Dam at the Ethiopian border to Sudan. And I believe there's a tape recording of the president of Egypt at that time deliberating whether we're going to have to bomb that dam because of the threat it would make. It's highly charged, and it's not just building dams. Even how the land is managed, if that will affect the amount of water coming downstream, has been an issue that's been debated actively in something called the Nile Basin Initiative in the last 20 years to try to see if people can agree and share those resources. Those resources, of course, water, hydropower, irrigation, but for the people actually living in the Ethiopian highlands, that water is their life. Largely it's subsistence agriculture, And if how much water there is, how much rain falls at the right time is highly related not only to how people do with their crops, but the entire gross domestic product of Ethiopia. So sort of the World Bank here track the water sort of more or less rainfall than average, and look at the gross domestic product, and it fit really well. So the rainfall and the supply of water is crucial to Ethiopia's entire economy. And well, that's nice, you know, it's worked pretty well, but it's not going to be working in the years ahead. This landscape, there are more and more people, and still 85% of the Ethiopian population lives in the countryside, involved in agriculture. It's where Sweden was about 120 years ago. Average family farm size is under a hectare. And the productivity has not been going up like it is much lower, but actually been going down somewhat. There's so little money for improved seeds and sort of pesticides, fertilizers. What's going to happen? So what people have to do is have to use more and more of the land and go right up to the top of these old volcanoes, mountains, where you get erosion. And how do you break this cycle? It doesn't seem to be breaking at all. We talk about a bioeconomy for the future. Well, in this landscape, it is a bioeconomy already. The dung from the cattle is gathered to use fuel for the cooking. There is a little bit of forest left in some areas. In the regional capital of Bahir Dar, there's a peninsula of this forest that's still. And in staying there, there's this shuttle traffic of papyrus canoes going from that peninsula to the city of Bahir Dar, about 100,000 people. And they're cutting down the last of the forest for heating, for fuel, for heating. And there's a sort of a hydroelectric power plant right next to Bahir Dar, generating electricity. But I was in a nice middle-class official's home, and he had a refrigerator and a TV. But the cooking on a stove, on electric stove, no, the cooking's got to be done over wood. So there's just this landscape is not it's not a good place to be a tree in this landscape. But there's a sense that if there were more trees in this landscape, that it would be better for everybody. There would be more water in the soil, more water in the rivers. The productivity of the landscape would go. It's not the only solution, but a part of the future of Ethiopia is more trees. And that's, you know, government policies, and everybody's in favor of it. And I myself, I've been in Sweden for 30 years. I really wanted to go to Africa 30 years ago, but I came to Sweden to work on acid rain. And after a few years in Sweden, I discovered that my university, SLU, had this 20-year project to develop forestry education in Ethiopia. And I thought, yes, my chance to go to Ethiopia. Well, it was 18 years into that program before somebody finally knocked on my door, and the first forest hydrology student needed a supervisor. I said, great, I'll be your supervisor. And the guy, I got to a Skype conference, and he said what he wanted to do. He wanted to model how putting forests on this landscape was going to improve the water supply in the Nile Basin. I was like, whoa, wait a second. I mean, the Nile Basin's a really big place. I need some data. And why do you think that trees are going to make things better? Because there's been this debate in the water hydrology community for decades about whether trees are actually good or they're actually really bad. And an important origin of this debate was in Scotland, an area that had been deforested several thousand years ago. And for various reasons, the British have been trying to reforest Scotland. Lovely tax breaks to rock and roll stars to plant spruce trees. I was educated in forestry in the US, and I thought I loved trees everywhere until I did my master's in this landscape. I was trying to find the water under those lousy spruce trees. My gosh, it was just crawling around looking at the ditches. It's not a very pretty forest. And economically, people were wondering, what is the value of those trees? I mean, sure, the trees grow, but will anybody be able to use them? And okay, you might make a little bit of paper. But this landscape is also supplying water to a very populous country, the United Kingdom. And people wanted to work, well, how much water are the trees taking, and what is the value of that water compared to the economic value of the trees? And they started in the late 60s 20 years of work, putting in dams, measuring with trees and out trees, and came to a very clear conclusion that those trees used water, and the value of that water was far greater than the trees would ever be. And a particular man named Ian Calder made it his campaign to go out and tell the rest of the world that forget about this myth of trees being good. And in fact, several, Bolin Falkenmark and Ewan Rockstrom sort of took up the challenge in the 1980s and did work themselves in East Africa, saying just because it's one way in Scotland doesn't mean there'll be another way in other parts of the world. It's a really interesting debate. And I suddenly found myself right in the middle of it. And I'm one of these people that earlier in my life, I loved to go out and dig holes, students, and look at where the water was going. And I just loved this cartoon. Look, a trickle of water running through the dirt. My afternoon got book solid. I mean, we love to go out and we love to measure things. And at one scale, in small catchments, we can cut down trees, we can measure the flows, and we see a picture. But it's not the whole picture because there are many different scales. And so what I'd like to do in this talk is give you a little insight into a dozen years of my own experience about are forests a part of the answer in East Africa? An answer on 3 spatial scales, small, medium, and large. And see where we get there. Oh, by the way, since we started Ethiopia now has a climate resilient green economy for the future with lots more trees in the picture. So trees are going to be coming. What will they do? So let's back up a bit there with Solomon, the master student from Ethiopia, comes up and says, I want to model the future of the Nile Basin. Now, first, you can have data if you want to do any modeling. And boy, was I ever wrong about the lack of data. Here in Sweden, we're very proud of our hydrological data. In Ethiopia, when the Aswan Dam was being built by Egypt in the 1950s, Haile Selassie sort of got the US government to help him install a set of rain gauges so they would see what Ethiopia was really contributing to Egypt. And they set up about 30 gauges in 1960. And they've been going since 1960, being read twice a day, 6 in the morning, 6 in the evening. When I first saw it, this is, the staff gauge like this on a big river can't be, what could be good? I've been looking at it more and more, understanding how carefully this is maintained. The rainy season comes, the staff gauge might get washed away, they re-put it in, they resurvey it to benchmarks, they carefully gauge the flows against the water stage. They've done a pretty good job on these over those years. So there actually is data to work with. So I was wrong. First thing I learned, there is data there. And Solomon, here he was before I started this PhD work, was going to use these series of data to look at what had been happening to the water flow, high flows, low flow, base flow index, and what had happened to the landscape, because there were air photos going back to the late 1950s, satellite data from the 1980s, and so we could look at catchments, how they developed. And we have catchments that have gone from 90% forest in 1960 to less than half forest. And others that have actually increased the amount of forest since 1960 with more eucalyptus plantation. We started working on one particular catchment that lost about 20% of its landscape. Worked very carefully on that. And what we found at the end of his master's thesis was basically this is talk about stationarity in hydrological data sets. Now, climate change is going to change stationarity. Well, this set of data was a beautiful example of stationarity in your statistics. The low flows, the high flows, the annual flows, nothing had changed over those 40 years of data that we've had, despite having lost 20% of the forest in that landscape. It was like, that was a really tough answer to swallow. Part of what we did was, though, not just work with the observational data, we were also working with community perception. There are elders here who were around in the 1950s when there was that forest. They were there when the forest was taken away. And you get in this participatory rural assessment method, you gather people together, you talk about the different time frames and what happened when the emperor fell, when the villagization policies came. And they were able to sort of tell us in their own experience of what had happened to the forest and what had happened to the water. And it was intriguing to see. We interviewed communities up in the highlands where there was the steep areas and the erosion and where much of the deforestation occurred, and in the lowlands. So we had the steep area communities up there, and we had down the lowlands, a big wetland basically, where near the gauge. What we discovered was, up in the highlands, they said the forest, when Haile Selassie was overthrown, there was a land of the farmers movement, and what the farmers did when they got the land was they cut down the trees overnight, pretty much. And then, the water, we didn't have as much water during the dry season after that. That was an upslope perception. Down here, the people said, oh, things have been pretty stable for a long time. Maybe it's gotten worse in the last few years, but they didn't see things change. Except for one thing they remembered. There in the early 1970s, the river started turning brown, which is when the forest was cut down. They're like, everything. So it's like, gave a lot of confidence in this, what the community had seen, and an explanation for why we didn't see a response in the hydrology, because there was a great big wetland sitting above our gauging station in the 100 square kilometer catchment. So maybe the gauging station had masked what had been going on. Solomon went on to do his PhD and work with more of those, about the 12 best data series we could find, and looked and did all sorts of statistical tests and the like. And at the end of another 4 years of work, the answer is still that we don't see any consistent change with changes in land use, even where we've lost half of the forest in one catchment over the course of 10 years. I was pretty discouraged about that, or, especially others, why don't we see things here? Is it because it's a matter of scale, and at big scales we don't see what people see at smaller scales? The answer, as far as I can see right now, is put together by some Chinese researchers who put together hundreds of these studies. And they say that it's not a matter of scale of where you can see the effect of land use on water flows in terms of what we can see in a river. It's a matter of how much rainfall there is. If you're in a very dry situation or a very wet situation, whether you have trees or not doesn't really show up. But you're in some sort of middle area of the temperate zone like Scotland or Sweden, and you've got not so much rainfall that the evapotranspiration from trees actually makes a difference that you will see. It's a great, nice explanation of what's going on. So the Ethiopian highlands with 1,500 millimeters of rainfall a year, another 100 or 200 millimeters of evapotranspiration doesn't really make itself seen. When you look at other factors about the aquifers, the geology, other sorts of variations, that's basically what we feel like we've learned at the medium scale. But while we were working on the medium scale, I was also working in Sweden with an economist who was looking at European forest policy. And he got really upset because he felt like Europe didn't want forests, because they didn't want to encourage forest expansion. And there was a concern from Southern Europe in particular that forests would use their water. And so I was talking to him about my Ethiopian work, and he was looking at his European policy, and thinking like an economist, he raised this question. He said, Kevin, the forests are supposed to be taking water. When they take the water from a catchment, a medium-sized catchment where we can measure what's going on, what do they do with the water? They put it back in the atmosphere. And thinking like an economist, he thinks it's like putting the water back in the bank. It goes back to the clouds and it comes down somewhere else. You don't get rid of the water, you just move it on to somewhere else. And if you don't put that water back into the clouds, maybe somewhere downwind is going to be suffering from not having that water. It was such a simple insight. And yet it's the work of Bolin, Falkenmark, you and Roxham and others to try to help us think in terms, see water, the water cycle in terms of blue and green water. Because if you're an engineer and you want to use water resources with dams and irrigation, you need this water in the river. And this water that goes through forests and grasslands and croplands is in some way, it's used once, but then it's lost to your catchment. So there's this perspective of water being taken away. And what David Ellison was trying to say was that, the very obvious thing is just because the water goes up, it doesn't come down. And it raises questions about where actually, if you take the Ethiopian perspective, the Ethiopian highlands are here, the green area. Where does the rainfall come from? Does it come from West Africa and the rainforest there? If West Africa experienced a deforestation like the Amazon, on the Amazon they say there's less rainfall, maybe 25% less rainfall because of the loss of the forest. There's talk of some of the ancient Mayan civilizations going under because of clearing the forests and leading to droughts. So there is this large-scale perspective that people have been aware of, but somehow it was still time to say it again to the research community, especially people like me who work on our small catchments and we see the water disappear. But at a larger scale, you want to be some sort of a global modeler like our Dutch colleagues Van Zeren. They can sort of try to model the recycling of water. How much of the rainfall that falls in an area actually came as evaporation or transpiration from the land somewhere. And the deeper the red, the more of the water that falls in the course of the year is coming from the land somewhere. And the Amazon, East Africa, northern India, those areas where there seems to be a lot of this recycling of water. Lena Gordon here at Stockholm University, our student Patrick Keys, they have done a lot to help people think about a precipitation shed. The management of water resources isn't just within the basin where the rain falls, but also the precipitation shed where the rain comes from. How you deal with that in a management framework is, I mean, we have so much difficulty managing at the small scale. Why we think we can work with this huge precipitation shed, that's another challenge. But it does seem to be larger out of watershed transfers that should be thought about. Anyways, what fun writing this paper saying this very simple thing about water is recycled. Also got us to thinking some more things of it's a matter of what we see in the water cycle, and to see that the water that goes up comes down somewhere else seems pretty obvious. It actually got us looking at these water cycles. If there's anything that people know about hydrology, you've all seen this kind of a picture in elementary school somewhere, right? It's simple, is it? Well, I started counting arrows, did people see the transpiration from the trees or not? And I don't know, when we did this about a decade ago, we never followed up on it. And then this guy, Ben Abbott, I told him about it, and he really took this to another level. And he and his students have been working with, they looked at hundreds of these pictures from around the world. They looked at pictures from China, from Russia, from France. They classify these pictures as who's publishing the pictures. If we look among scientists in their different works, books and journal articles, they looked at different disciplines and looked at what percent of the diagrams included important sources of water, like precipitation on the land. Everybody got precipitation on the land. And everybody pretty much got evapotranspiration as two components of these water cycles. But when it comes to surface runoff, snow, ocean evaporation, by the way, is the big source of water in the atmosphere. Not all of the diagrams actually show it. And when you get to what people do in the landscape, that's really not many of these diagrams show people in the landscape. But I was like, we need to think again about the message we're giving at the very basic level about how water works. This larger scale, it's not so simple. We're not giving a very clear picture. I'm not just sure what the clear picture should be. We've sort of worked with what would the totally perfectly correct picture of the water cycle be that is unbiased. And it's going to be 80% ocean and a little bit of land. And that's not very good. I don't want to see 80% of ocean. And already I'm falling into the trap of providing a sort of a biased view. So why should I complain about other people's biases when I don't want to see 80% ocean? So at the large scale, there's some interesting things to think about. But this large scale that I've been talking about is the supply side of water being supplied to the atmosphere is only a very simple mass balance. There's a whole other aspect about forests and water, which is what the forest does to the soil in the sponge effect of letting the soils hold the water, or even creating a sort of a situation where precipitation will occur. Forests change the atmosphere. They put up these aerosols that help clouds form. There's a lot else going on. And quite frankly, if you're concerned about water from the point of view of food security, these global pictures are very nice. What can you do with it? Even the medium scale that I, as a hydrologist, love to work on, river gauge that's been going for 50 years. Well, if I'm a farmer and I want to decide whether I've got enough, if I need to irrigate or if it's time to plant the crop, think about my tomatoes here in Uppsala. I don't go down to the Ferus River and look at the water level in the Ferus River. I put my fingers into the soil. So there's another small scale that is really the most relevant for the subsistence agriculture. And there are people that have been working on it for ages. Hans Herney during the 1970s, Thomas Stingley during the 2000s. I mean, people made from Western universities have made some great investments of partnering with Ethiopian universities to understand these. One quick example of this, a colleague from SLU, Ida Vargus, who did her PhD. She had sort of seen this debate between is the forest a sponge or is the forest a sort of pump that takes away the water? And she saw that maybe these two viewpoints are a continuum. If you have no tree cover, then you really lack the sponge effect. But if you have a lot of trees, then you see a lot of the pump effects, that maybe there's an optimum about the number of trees in a landscape for getting the water right for farming. And she did an incredible amount of work in Burkina Faso, instrumenting a landscape under the trees, in between the trees, TDR, soil pits. Oh, she worked hard. And she found just what she'd expect, that it's some sort of mixed landscape of agriculture and trees. They got the water held, but not too much taken by transpiration. They had a sweet spot, which the farmers could use for doing what we call agroforestry as a nice way. I think they worked for 5 years on that. It's elegant, it's beautiful. And it tells us about one particular landscape region under one climatic regime. And what can we say about the next area? Is this going to apply in Scotland, where this sort of whole forest water yield debate began? And this is where as a hydrologist, which is, I will admit to what I am, we have this dilemma. You would think that water is so simple. If I take water here and I pour it on the floor, some of you could probably with a paper and pencil work out what every single molecule is going to be for the, as the water fell, where it ended up. But if I put a flower pot between that water and the floor, your biggest supercomputer couldn't work out where those water molecules are going to be with the same sort of, tracking every particle, because the vegetation has got its own strategy. It wants to get at that water, so it puts down these roots. Water is very simple. It goes downhill. It goes from high energy to low energy. So it goes down, except when you have plants, and then puts much of the water up again. And those roots aren't bad enough that they're there pumping the water up, going the wrong direction, but then they die, and they create organic matter in the soil that hangs around for decades, zombies changing the soil properties and making the soil so very complex. We put some sort of tracer and see where the water goes. So do we need to know about all this complexity? I mean, we've got these lovely dams all around the world that were made with some very basic assumptions about hydrology. We can do great things. Do we need to know all those nasty details? Well, some of you might be old enough to know, or have liked old animated cartoons, to remember Mickey Mouse and the Sorcerer's Apprentice, where he's got the job of working for a sorcerer, cleaning the floors. And he takes the sorcerer's hat and figures out how to get the broomsticks to do it on their own. It's great technology. We've got the technology. We can do things better. But the problem, it gets out of hand. He doesn't know how to really control the technology, and it all floods. And, it's horrible. Well, these things can easily happen with water. If we think we know what's going on, we can do some things that are really wrong. And I'll be really provocative to say one thing what I think would be really wrong with you with our understanding of water is to do water footprints. I mean, we've got carbon footprints and the ecological footprint. It's nice. We got a water footprint. Take a piece of this paper. If you grow it in Sweden, it takes about 8 liters to produce a sheet of A4. If you grow that paper or the trees for the paper in Brazil, it's only 4 liters of water. So, simple conclusion, we get our paper from Brazil, right? No, it's not that simple. Water isn't a pollutant like carbon in the atmosphere. Water is something that needs to be managed at the local scale. And much as it's been fun to work with these river data for decades of river data, and to see what modelers are doing at the global scale, there's a local scale of understanding the water cycle that is really important, that it's going to take lots and lots of people that know about water out there. And so to me, what I've learned in the last 15 years is what I feel most important about is to get more people learning about water. In Ethiopia, they are expanding the university system tremendously, and there aren't enough good teachers, unfortunately. It's been a real fun to be there and meet students that are really happy to get some supervision. But even here in Sweden, I'm very concerned about, are we going to have enough people who actually know about water? So I spent 6 years at Uppsala University because there's some really good hydrology education. Here at Stockholm, you've got some basic hydrology education with some great teachers. This is really important that we get trained here in Sweden and the rest of the world gets to know about how this water works in this nasty, complex soil environment. And with that, I would like to say thank you.
Thank you very much, Kevin. It's really nice to talk to and then to listen to a very interesting presentation. I'm a hydrologist myself, so yeah, great. So please, if you have any question to Kevin, yes, please.
Hi, thanks a lot for the nice presentation, a lot of information. I especially like this deep work on taking a part of the optimum design between the dense forest and low forest. Do you think that it's like the optimum could be itself climate dependent? And
absolutely.
Specific for that region, or would you say in Sweden we would have the same situation?
That was my point, is that for that climate and that soil and that purpose, that sort of crops, there was an optimum. But that optimum is not going to be relevant somewhere else. I mean, for Scotland, the optimum was, for the point of view of providing water for the downside, was probably no trees whatsoever. So the optimum is partly what our goals as people are, and very much what you're given in the way of a playing field and players to work with, which is why the local knowledge is so important. And water management for people living on the land is very much a local thing. I'll be very happy to talk about these regional flows, but we don't know how to organize management at that huge scale. So I'm a big fan of local knowledge.
I would be especially interested in the need to have these kind of fields and elements all over the world. Or we can find a model that can maybe understand all the processes in order to generalize.
There may be, but I was examining a thesis here on water harvesting. I was one of the Stockholm Environment Institute's students. They'd been designing water harvesting schemes. What was the right number of water how should you place in the landscape? And I was examining, hearing, and as I realized in the middle of the defense there was this animated discussion about overland flow, whether the model that was being used to design these rain harvesting things was adequate because it was based on overland flow or subsurface flow, which is something that, I mean, Sweden with the work of Alan Rode and Eric Eriksson really opened up the world's eyes to how much water that was in the soil was rapidly contributing to runoff generation in the temperate region. Haven't we dealt with that? Don't we know that? And it's still very much alive and very much unknown. So yes, models could do it if we knew what it is we were modeling, which is why I would say that, modelers are great. They can help us try to do things, but they're especially great at posing hypotheses and say, is that model working the way we think it is in that region? So lots of room for modelers, but again, that local knowledge, I don't think will. All right, how comfortable are you with your models? Would you sell your model to a person whose family is dependent upon getting when you plant that crop right? Do you have a model that's going to help them?
No, I completely agree with you. We need to work from a hypothesis point of view.
Thank you, Kevin. It was really engaging talking about the atmosphere, land, ecosystem interaction. It's a very important area. I agree fully with you. Just a comment and perhaps a little question in the end there. If we change continent, go to South America, you probably have heard about the river water in the air. There's been a lot of discussion actually. You have strong political implications of the deforestation of the Amazonas and the drought in the south of Brazil. That is the Sao Paulo area where it's a real big concern. We have so many millions of people living, and that actually caused Lula to take the initiative to stop deforestation in Amazonas. That changed now. We'll see how things go. Yep. But unfortunately, connecting to your discussion here about models, it doesn't seem really, you might have heard something else about it, but that you could confirm this really in models. It's more a hypothesis that you're looking at, and that the deforestation has caused such a change in the pump of water up in the atmosphere that it actually affects the brain. There's a strong consensus, I think, that wherever the water comes up, it comes down somewhere else, right?
At that level. But the detail.
So I'm really saddened by your comment that you have to go to an economist to learn that there is a thing, and you didn't go to the meteorologist instead. It's kind of funny.
It is funny, and
precipitation actually in the area to see how that varied and how that worked together with the precipitated runoff.
First of all, it's just that we get in our disciplines. I mean, that I'm around great meteorologists, but don't interact with them. And it's just like, wow, why did an economist have to raise this? And how do we manage to get this idea published in a really good journal when it should be obvious to a lot of people? But there was the modeling community working on this forest recirculation. There was the small catchment people in their world. They were very happy working in their own worlds. We hadn't communicated enough, and it's always nice to be able to make those connections. Now, I can tell you why. If I was actually speaking to a meteorologist, and we did try, I really have been trying to understand where the water in Ethiopia comes from. I mean, I've actually asked for the paper. There's a group in Norway that actually tried to work out where it comes from. And to read those papers, it's like the water goes this way with the wind. It's like water goes here and it goes up and the pressure changes and the water holding capacity is like, it gets really complicated really fast. And we've been trying to, we haven't managed to get our paper published about this yet, in part because the editors wonder, well, what's the answer? How much of the water in Ethiopia comes to the West African rainforest? No meteorologist can tell you what it is, so why the heck should I as a hydrologist tell you? We're just saying it's really important to think about that West African rainforest, partly because the evapotranspiration from the rainforest may be coming down on the highlands, but the biggest thing that we've seen, the real kicker, is the regional flows of air. If you change that landscape in the West Africa, will the flow, whether the directions of flow across the African continent change and bring these rains that have been falling on the highlands somewhere else that's not used to it? So it's this regional patterns that seem to be a very sensitive thing, and who knows what that's going to be. So, but we might have a great experiment going on if and when the deforestation of the Congo takes place.
Perhaps we should start talking to each other more.
Yeah, we should. Yeah, it's unfortunate. you get to my age and you have these insights, and then you realize, well, I'm in meetings all the time. So that's why I like to come out and, don't make my mistakes. Oh, it's so easy. Talking is very important. Coffee is very important. And Swedes are very good about taking coffee breaks, unlike other cultures. Coffee, by the way, is found in Ethiopia. It's native to Ethiopia.
Thank you very much for the talk. I have a question about the water quality. You mentioned that the rivers turn brown, and that should have a large effect on local communities, both and also biota and biodiversity in these river systems and so on. Is that anything you have worked with in connection with the amount of water?
Very glad you asked that. I've just been told I've been working on this lake, Tana, been now for 15 years, and I haven't been back for a few years, but somebody told me it's turning green. It's eutrophied. I mean, the big, I was like, wow, boy, wish we'd started some long-term monitoring of water quality 15 years ago, but it hasn't been on the agenda when I started visiting Ethiopia, among the people I was talking to. But now when I meet the students at Addis Ababa University, water quality issues are coming up. About the pollutants in the city environment and what's grown with the irrigated water. Eutrophication, we'll be hearing about that on Lake Tana now that it's going eutrophic. It's Agenda 2030, the new goals for the whole world. I see a great possibility that the way that the industrialized nations have worked systematically with monitoring the amount of water and the quality of water and other aspects of our world will now be a part of how the whole world works. It's not just poverty and food, it's quality of the environment, which has a lot to do with how ecosystem services that we can grow food or not. So I hope there will be more interest in other aspects of water besides just the amount in this forest water discussion. But something that this brown water very much affects. When we first went to work in Ethiopia, when I ended up there, they hadn't built an irrigation scheme, a medium-sized irrigation scheme of say 10 or 20 square kilometer catchment for 30 years. And the last one they built, apparently the dam had filled up overnight due to erosion, just, full. So this place we were working, this catchment with big water, the big wetland, well, that big wetland now is a 5-6 square kilometer irrigation reservoir. And it's got a 20-year lifespan. If they manage to reduce erosion by something like 80% for islands, but it doesn't look like they're going to reduce the erosion by 80%. So they built this great big irrigation stream, allowed some farmers to irrigate and grow crops where they hadn't before. But you just wonder, was this really what that landscape needed, knowing that the erosion is going to cause this reservoir to sediment in? Why, when it's so difficult to get a little bit of money for fertilizers and improved seeds, can we somehow find the capital to invest in an irrigation scheme? I just don't understand how it goes together. But irrigation schemes are the way of the future. Ethiopia's, they've got the capital, they're investing in this, and a lot is going to happen. And it's another research opportunity. What are the trade-offs of putting in this medium-scale irrigation versus other ways to develop the productivity of the landscape? But it's so many social issues around this. I mean, not just, well, here are the technical solutions, but what do you do with 85% of the population that's working in subsistence agriculture? If you make farming more productive, where do all the people go? It's going to be a huge exodus and urbanization and all that. And what are people going to do? So, I don't know, but learn some hydrology.
It's okay, you don't need
Hello, I just would like to have an additional question to this erosion problem. Because in one of your slides you showed that there is some optimal amount of trees which is important for water management in agriculture areas. Has somebody checked if this is an optimal amount of trees for the erosion control in the area? Because it didn't look natural, and what's not natural will cause groundwater, and agriculture areas it will cause green water.
Many aspects of that answer. Trees, I think, have been shown to actually reduce the erosion of the landscape. This work of Hans Hörny in the 70s, wonderful, all focused on largely on erosion issues. But what trees? People love to hate eucalyptus, and that is the tree of choice in that landscape. And it doesn't promote a land cover that is as resistant to erosion as other trees. So it'd be lovely to have these old natural forest, or sort of the forest with many endemic species back, but that does not seem to be what reforestation means in the context here. So not just about how many trees, but which trees. And it's a very good, I mean, if you just sort of keep the cattle out of the area, trees will come back in this landscape. It's not really hard to get trees to grow here, but it's a matter of making the decision that that's more valuable than something else. Thank you.
Hi. Just to add yet another potential scale to this, the paleo scale, kind of paleoclimatology. It seems to me that seems to be great uncertainty in Ethiopia, for example, about where the moisture comes from, forests, or when I think about, say, well, Ethiopia is created of civilization and has been growing human evolution, and one of the potential drivers of that has been the drying of an idea that's there, I know, relate to, say, monsoon, changes in monsoon delivery of moisture. So can some kind of perspective be gained through looking at this paleo moisture records?
I'm
ice cores,
yeah, that's no.
Maybe like speleothems, so I don't know if anybody looks into this.
Yeah, there.
Yeah. Okay, so this seems
Great. Yeah, I mean, paleo people are my heroes. You know, I work away at these, try to understand the process, run around in the rainstorms. You know, colleague goes out, takes a peat core, and goes back to the lab. They've got it. They've got 10,000 years right there and tell us pretty much everything. So there is a lot to be said there. The sensitivity of this landscape to these changes. What did it? It has probably had different climates, and what was connected with those different climates. I've been more concerned at a local scale. We have air photos back to 1960. What happened 100, 200 years ago with the forest? This idea of the deforestation of Ethiopia, there's been a lot of people, and they've done a lot to the forest landscape, and has been up and down in different areas at different times. So there's a lot there. But to get the land cover and the water, but they do amazing things with tree rings and isotopes. And so how are you doing on the speleotherms? What are you finding there?
No, I mean, I studied the continent at first, but I heard some different because I'm Ethiopia that they're working on.
Right. I know the tree rings have been studying there. We've got a few hundred years back on the amount of rainfall, they believe, from the isotopes they're trying, but I haven't really seen it put together as well as I'd like.
I would just like to add that this last Friday there was a PhD defense coupling diatoms and land use change and changes in hydrological regime by these agents. That would be something to look into if you're more interested. Tanzania.
This is the diatoms of things that grow in the land, and they see it
in the lake.
On the lake.
Looked at how aerobic they were, I think, to see how the lake dynamics had changed, and then couple that to the changes in recent terms. See if that was a modern fluctuation or not.
Yep. Great.
Just a plug.
Yeah. All right.
You keep referring to Ethiopia or the Ethiopian highlands, but previously you were talking about catchments. You've got a tendency to talk about these two in two very separate terms and tend to generalize about the Ethiopian highlands. But I mean, that's a big landmass, and there's a lot of orography there, and precipitation is going to be very different in different parts of the areas. I'd just like you to comment on this dichotomy.
There is a lot of variation there. We've got one of the first things Solomon did was to look at the different, basically these 30 flow records and see how different they were. And they were very clear that all within the highlands, differences in the runoff coefficient, in the flow regime, seem to be largely related to the underlying geology, because it's not one uniform geology there. And then the amount of precipitation with this landscape. There's this beautiful map of the rainfall with rain shadows and area. This you go up the hill slopes and there's more rain there, and you get the other side of the valley. So there is a lot of variation there, but it is still a very humid region. So I don't think there's no place that's really dry there. But there are different soils and different amounts of water there. But it's nothing that I've come up with. So generalization, yes, us academics love to do it. We see a few things, and I give a talk about this like I know about a whole lot more. So there's plenty of variation and lots to be learned from it. This again is this: how important are the trees? Solomon's opponent was saying, why are you focusing on this much of the soil when you've got a whole aquifer underneath? And that's what we'd seen basically in looking at the 30 different rivers, is that it's the aquifer that determined what you had for dry season flows. Then but if you're living on this particular catchment, you've got the aquifer you've got, and then you try to manage as best you can from that perspective. So, yeah. Oh, let's see. There was a person behind you who had their hand up first, but then we'll get to you. Right. So, okay. We come here. All right. All right. Sorry.
I would like to link back to the question before about complexity and like what's the best tree cover for water management, but other things as well, like erosion. I would add other things like fire risk and also the social component of the environment. So the point is that it makes sense to study just best cover tree for one thing, or we should do more complex kind of studies. And how complex can a study be before being like in much? And related to this question, another one, very short. It's about the other side. It's about how to make simple thing work, like the water footprint, for example. It's a very simple thing, but sometimes can be misleading. And so what's your opinion about, for example, the planetary boundaries framework and the fresh water boundary, which is just one measure that tells everything, right?
Right. Wow. First of all, complexity. Just so to say, there are many different scales, questions you can address. Whatever scale you choose, try to do it well, think critically. There's probably a relevance for anything there. Being sort of more pragmatic as a supervisor in most cases, most of the work I do is through PhD students and postdocs. What can you answer in 3 or 4 years? And try to do something there, which gets in the way of the grander syntheses. But for some people, the grand synthesis is what they need to do in their 3 years, and they'll manage a bit, which gets back to the need to talk to each other, because we're all that sort of blind man and the elephant. We all see a part of it and can try to see that part well, but have a lot of respect that it is only one part of the whole. So simplicity in study so you can get it reported and done, but also even in putting things together, there can be an elegant simplicity. It requires a sense of not getting lost in the details and yet still having a sense that there's a whole forest out there. Comes to planetary boundaries. Ooh, that's a big one. I think the idea that there's a need to try to get people to act and be aware that there are problems, and planetary boundaries fits there well. But I'm deeply uncomfortable with the idea that science can know anything in an objective way. We are a very social business. What we agree upon is because we agree upon it. Not often that we can make this one wonderful measurement and show that 1 + 1 is 2. Much of what we do in science is a socially agreed upon thing. And if you have that perspective to say that this is the boundary, that was a value judgment that somebody made. And to lift it up as a boundary is also a value judgment we're making. Why are we doing that? What are we aiming for? I get very worried about this is the way, we must do that. I mean, we have a lot of choice as people. Somebody said, I can imagine lots of sustainable futures, but not many that I'd like to live in. We have a lot of choice as people, and if anybody tells you have to do this, I immediately, react against that. But then I just sit at my, little table and study my little things, and we'll never get any actual change. And other people with a very clear political agenda will get done what they would like to get done. So, hope that answered that diplomatically.
Yeah.
You had a
Just
question.
small question. What do you think will be the effects of the Renaissance Dam, and how long will it last? The dam?
I think the Renaissance, this is strictly, without having studied, I'd say Renaissance Dam is probably last a good amount of time, and it'll probably work at producing a lot of power and providing a lot of irrigation. The trade-off is when you go with irrigation, that's water that's not going to be going downstream. So, I mean, the beauty of the Blue Nile is that it's very deep, it's very cool. That is the place to do the reservoirs to generate hydropower without losing as much of it to evaporation as you do in the Aswan Dam. So then Ethiopia is building lots of hydropower stations, and they're saying this is good for the whole region. Probably is. It's the irrigation that gets tricky. There's a river, there's Lake Turkana on the Kenyan-Ethiopian border. It's going to be the next RLC. Ethiopia is building a series of hydropower schemes on it. That wouldn't threaten the lake. But then Ethiopia said, also, we're going to build some sugarcane plantations. That's going to dry up Lake Turkana. It was a good idea to have cotton plantations to dry out the RLC. The world seems to have reacted pretty strongly against that. I haven't heard much at all about what's going to be happening to Lake Turkana. But, so, yeah, it's trade-offs. And who is to decide that? And, it's a lot of people are, looking for their livelihoods for the future. So, that was a little question, right? Thanks. Boy, I hate to see what you call a big question. Does that answer? What would you say? What do you think about the Grand Renaissance Dam?
It's too big.
Too big. Hmm?
But I don't know how to convince the Ethiopian government to build small dams or more solar power and wind power.
There's a small dam. Is that a good idea? It's going to be filled up in 20 years.
Yeah.
The Renaissance Dam, you can probably, bottom flush it and things like that, and make it last. I'm not a dam person myself, but it's.
But you want that cause earthquakes or things like that.
I don't know, not like it's not like the Three Gorges Dam in China in terms of tectonic activity, but so there are many aspects I wouldn't want to know. But it was intriguing that Ethiopia was able to build basically nothing for half a century. Couldn't get the capital, and now they do have it. So things have changed a lot in the last 10 years for the dam building in that part of the world.
A related question out of ignorance. You talked about Ethiopia, you talked about Egypt. Is there anything going on in Sudan? Politically, it's a mess, but they don't seem to extract much water for irrigation on large scales. It's all local, or is that?
I believe they have irrigation schemes there, and there have been plans for over almost 70 years to put a canal through the Sud swamps. I mean, that would be the thing you do. I mean, the White Nile evaporates in the Sud swamps. if you go through, do we need the Sud swamps, or can we use that water by channelizing that? So I don't know what's happening there. It's being so caught up in the internal, the troubles there. But it does have irrigation and its own dams. It could benefit a lot from the energy from the Grand Renaissance Dam.
So, thank you so much, Kevin.